Talk about this one, importing DLLs. And so here you can get this hello 4, and this is a simple program just like the others. Let me copy the link address and download this program. There's just a couple of cute tricks to learn here. All right, so there's hello 4. I save it. And that's going into my downloads folder. So if I don't need an administrator command prompt, an ordinary command prompt will do. All right. So hello 4 is right there. So if I run that, it just says hello. I use DLLs. All right. So we can examine that in PE view. And go to downloads and hello 4. All right. And we can look at the import address table, which is here in the iData section. Notice it has more sections than some of the other programs you've looked at. You can have a lot of sections. You just always have to have a text section, and almost always data and R data. Then there are other sections that some executables have and others don't. But this one puts the import address table in its own section, which is not always the case. And here you see all these Windows API calls it makes, which is quite a few. All right. All right, so we get the DLL name. All these API calls come from kernel32.dll. All right, and now we can see the addresses. If you look at the raise exception here. Okay, let me, you can see the addresses. I'll just go through one of these because it can get a little confusing. So the raise exception is at 5954C. And, yep. And so if you look at the iData section itself here, 5954C is here, and it contains this address, which is in Little Endian 5D9DA. That's the 32-bit word stored at that address, and they're actually stored in the file itself. All right, and so that tells you where the import hints and names are. This is how the import table works. That's going to point you down here to the iData section to the hints and DLL names, and you'll find the name of the API call down there, raise exception. So you can see the structure of an import table. And the point of this one, which I don't think I'm going to go through live, is how to fix broken import tables. So one of the tricks that's irritating is Microsoft modern operating systems have address space layout randomization turned on. So when you launch a program, it will actually launch at a different location in memory than 400,000, which is where it would naturally want to be. So if I run this hello 4 in OllyDebug, let me bring up my OllyDebug. All right, and now I open downloads. Hello 4. Okay, so now that program is open, and notice I'm not anywhere near 400,000 here. And if I view the memory, hello 4 did not load at 400,000 at all. It loaded at 12A0,000, way far away from 400,000. So that's address space layout randomization. It randomly moves it. And if you want it to stop randomly moving, which is not good for security, but it's very good if you want to analyze things, then this cool tool here, Set DLL Characteristics from Didier Stevens, will do that for you, which is very nice. So I'll download this thing. Okay. And now I will go into downloads. And here's set DLL characteristics, so I will extract that with 7-zip extract to a folder. Okay, and there it is, set DLL characteristics. Okay, and now I can run it, and -D will clear the dynamic base flag, which is ASLR. So I can modify that file. What I need is a command prompt, and I'll go into downloads and then set. Okay, and here if I look, I have that program. And if I do a dir of ... above here is my hello 4. So I can run it this way. I can run set DLL characteristics -D of ... /hello.4, and that will change that flag. So it didn't complain, and I don't know what all this garbage is. Visual Studio opened. Whoa. Maybe I ran the source code. I ran the C source code, not the executable. Oh, okay, that'll do it. And running the C source code launched Visual Studio. Well, that was rude. And now I can't figure out how to get back. It won't stop with Control-C. It does stop with Control-C. All right, let's try that again. But I've got to run the executable. There we go. And so now it changed the dynamic base pointer. So now that program will load at its default location. So if I run OllyDebug again, all right, and get rid of all this complaining. And then I open hello 4. And now I view the memory map. Now here it is, right at 400,401, right where it ought to be, so it's easier to analyze. So that's a useful trick. Anyway, so there's a couple challenges to do with that here, where you can examine these import tables, and you can find a broken import table and fix it as long as the error is pretty simple.